an end-to-end, fully autonomous scraping, web scraping agent still does not exist. Let that sink in. Hi everyone, I'm Iván Sanchez. I'm a data scientist at Site, and I actually don't want this to be a boring talk. I want to do a full reflection with you here about what is the current state of agents, how they have evolved, and especially trying to focus more about how they are helping us doing the web scraping tasks. Sorry. So, again, I want this to be a reflection. I'm going to be talking about our journey inside, how we are currently investigating and researching the current evolution of agents for both software engineering, but also for web scraping, which is the thing that we are focusing on. First, I will be doing a quick introduction on agents and types of agents, because it's really blowing up how many different options we have for agents nowadays. And in general, why companies shouldn't be underestimating agents, why everybody should be paying attention, because this is just not some kind of hype that has grown up. It's really something serious that we should be considering, because it's really a time saver. After that, we will be checking or thinking more why maybe software engineering is more suitable for agents, and why web scraping as a task is more complicated than software engineering. And at the end, I will be giving some details about what we are doing inside and why we are investigating what we are finding out, and how all of this can be improved in general for web scraping. So what is an agent? Agents have existed for a long time already. I mean, this is not something new. An agent is simply something that gets an input, which can be the observation of the environment. They reason, which, let's say 10 years ago, it could be just some rules written in software. And then they act. They output something. They act on the environment. For example, some NPC from a video game, that's perfectly an agent. And they have existed for years. The thing is that agents right now have the powerful brain of LLMs, which is the reasoning part. And this is what's bringing agents to a whole new level now, and what they are being so important, and why are becoming such a great thing. But of course, there are several types of agents depending on what are the user needs. So we could say there are different agents depending on these three different things: whether they code or they execute actions, whether they are local or remote, and if they are fully autonomous, or they usually, work with the human in some kind of human-in-the-loop fashion. Now I'm going to present you some frameworks that have been growing during the last year. There are really many of them, but these are the most important ones, just so that you can see how many different options we have right now for agents and for workflow. So I'm pretty sure most of you know N8N, which is like a workflow automation task where you can just drag and drop boxes around, and it has so many integrations. So this is more like trying to make the business workflows more achievable for the person that is not really a developer, and it has so many integrations. So this will be more of a fully autonomous thing, and it can be local or remote. It doesn't really matter. It gives you the different options. And in general, this is not so much a coding agent, but something that executes actions. There are similar ones like Comfy UI and Gabber. All of those are open source. But then we have OpenAI Codex. This is more coding oriented, but as you will see, this is kind of different from other ones that are more human in the loop, because this is more designed so that the user gives a task for the agent, then the agent works as much as it needs, and it creates a PR that it will be reviewed by the actual human. So the level of interaction here is minimal, and for a reason. There are other ones similar, like Google Jules or Claude Code, with are kind of also very new. And then we have this kind of new thing from OpenAI, which is the agent mode they have in ChatGPT, which takes a user query and then it starts browsing. This is super interesting because it kind of tries to mimic how a human would approach, access to the web through a browser. But if you've tried it, you will very quickly see that it has many limitations that we humans don't have. This is a very interesting point that I will be coming back later. And of course, there's the Google version of this, which is being developed as we speak now, and it's already being rolled out in the US, which is the agentic capabilities in AI mode, which pretty much does the same, but it fully integrates with everything else from Google, which is Maps and other different things like the search engine, and which brings like more value to Google when it does it. And then we have the Star. We have GitHub Copilot, and there are similar ones like Client or Cursor, which are, also coding agents, but they're more human in the loop oriented. They are designed to be more like, co-workers or peers that you do dual coding with, and then you go back and forth accepting the options it gives you, but it also has the ability to execute commands, which is very powerful, and see the output of the test, which gives this level of autonomy that makes your productivity really scale. Is this hype? I wouldn't say so. I mean, of course, when there's so much money being put in, and when there are so many people talking about it, there's so much FOMO around, right? We may think that it may just be hype. But, this last year and seeing these quotes, I don't really think this is just hype. I really think this is some kind of LLM thing when ChatGPT was appearing in 2022, if I'm not mistaken. Everybody was adopting it super quickly, and it was really driving up the performance of everyone that started using it. And this is no different. I mean, this is just agents backed up by those LLMs, which bring this productivity increase to the power of many levels of magnitude, because it has this ability to act on your behalf and act upon what responses it's getting. And also, there are many surveys, and this is probably the most important one from Stack Overflow, that is showing that the adoption of developers of AI tools is just increasing. Last year it was 76%, right now we're 84%, probably next year it will be right above 90% of developers. So that's pretty much everyone using AI tools right now. However, all of that was for software development. So it's very clear that agents for software development are great. They help a lot. But what about web scraping? Is it the same? Can we really translate how good agents are in software development to web scraping? And the simple answer right now is no. It's very easy to think about it. What do you do when you want to scrape something? What is the thing that you usually do? You open the browser, you go to the web page that you want to scrape, to get the data from. Bam, you get a CAPTCHA. That's it. I mean, game over for the agent, right? Of course, there are things we could do. We could provide the agent with some kind of browser that surpasses these kind of blocks or bans. For example, Site API browser. But then you have a huge web page that, let's say, some Amazon page, it's perfectly more than 1 million tokens long HTML. That's another game over for an agent. I mean, even if it's backed up by the most powerful LLM there is right now, which is probably Gemini 2.5 Pro. And I say this one because it's the one with the biggest context, which is 1 million tokens. It can't just work with such long HTMLs. So it can't even start understanding what is the data that has to be extracted. And that's very important too. That's another reason why web scraping is so hard for agents and for LLMs. And this is way beyond the typical task of software engineering. Software engineering you can think of it as some files that are maybe 1,000 lines long, and you can work on them, and sure, you can test them, but as you can see, web scraping is more dynamic. Also, there's the problem of dynamism. Okay, let's assume that our agent works well, and you have perfect code that extracts. You have perfect code that extracts the data just as you want, and then you go back 1 week after, and you try to extract the data again because you just want periodic scrapings. And then you realize that the web page has changed. I mean, this has happened many times, right? Our favorite web page, you just go to a web page and you see, hey, it has changed. Nobody asked for this, but they changed it, right? And we humans are very good at it, and we adapt very well. And we probably, just 1 second in the web page, we already see something has changed. But that's not so easy for agents. We need some kind of monitoring. And sure, we can have the agent, do the full one-time coding to extract the data, but then you have to go back to the monitoring part, and you need to rerun this every time, and you need to understand the bigger context. And that is even harder than the other problems that I was posing. So it's clear that there are a lot of challenges when we talk of using agents for web scraping, but for every challenge we have solutions. And this is what I would like to think with you. What can we do to make it easier for the agents? So probably, it's very likely that all that I will say here in 2 years, it will be completely outdated and it won't be relevant anymore. But we have to think of today. Because, as I said before, there's no agent right now that solves the problem of end-to-end fully autonomous web scraping. Who's going to get that first? So to get that first, we have to, right now, with the technology we have to solve those challenges. And here, we perfectly have, for every one of the challenges, we have a solution. We can simplify the HTML. We can create fixtures and tests to check that everything is going fine when we write the code. We can access to unlocking browser to download the HTML and to not get banned. We can monitor, for example, inside we use for Scrapy, we use Spider-Man to monitor if the code is still working. So we have the tools, right? But how do you compose all those tools with an agent so that you can accomplish this task? And this is really not an easy thing. At the end of last year, in 2024, when agents weren't nearly as good as they are today, at Site, we already started thinking, how can we automate this? How can we make so that we have the LLM writing code, but we test it at the same time automatically? Because LLMs were already very good, and our developers were using it to write spiders and to write extraction code. But we could go further, we could go beyond, and we could, automatically detect the target values that wanted to be scraped and automatically test the code that the LLM was generating, and then saying, okay, I have some code that works well, give that back to the developer. So we created what we're going to call like a mini agent. I'm going to call it mini agent because it was actually some kind of agent, because it had inputs, which was the requests from the user, and it had some internal loop that created code and checked if the target values and the extracted values were the same, and if they're not the same, it would go on trying to get better code. You have here the full pipeline, and this was created internally as an API to try to help our internal developers writing code. It was well accepted. It was already saving time. But then fast forward to basically now, 2 months ago, 3 months ago, we started seeing how agents are becoming so much better. to the point that we started thinking, is this still relevant, what we did? This mini agent, can we just tell an agent to do all of that and maybe it will be able to pull it off? Well, I can already say that we are all the time trying to do this to see if all that we're doing is relevant. And I can tell you that even the most powerful agent with such big instructions file, it's not able to even come close to what a real end-to-end fully autonomous scraping should be able to do. Here you just have an example of how quickly the agent goes off rails when you don't help him in any way. You just give the instructions and it's already giving you some target data by inspecting the HTML that it does not conform to the schema that we were asking for. And from that point forwards, everything will be wrong. So we really need to help the agent. So we were thinking, okay, let's try to use our mini agent, which solves many of these problems. And that mini agent would help this bigger agent with that kind of task. But how do we do this? So there are different ways we could approach this. So the initial idea, the most obvious one would be, okay, let's put this mini agent behind an API and we make the user register inside, use their site API key, and we charge the user for that. But after we were thinking about it, we didn't really like it so much because there were better options. You know, with MCPs and trying to make the user have to register for something that is just using an LLM under the hood, because our mini agent is basically that. It's a piece of software that is using an LLM here and there, but it's not so complicated if you think about it. So there's this MCP sampling in which I won't go into many details, but this was exactly what we were looking for, because we wanted the bigger agent, which is VS Code Copilot, to have access to the code as it was being developed by this mini agent. We wanted full integration with this agent, with the bigger agent. And that was achievable through MCP sampling. How does this work? The idea is kind of simple, but can be hard to understand. So instead of having our server that would make his own requests to the LLM provider, for example, OpenAI, what we are doing is we're allowing the user to have all the code that we developed of this mini agent is on your machine. And what is happening here is that the prompts and the requests that our mini agent has to do, they're being routed through the LLMs that your VS Code Copilot can provide. And this way, you can have it much, much cheaper than if we did the calls ourselves and we gave you this service through an API. And also, we're allowing you to see what is going on under the hood and having the code running in your machine. And at any time, you could pick what is going on. And we think this transparency is also very good for user adoption because it's clear what is going on and we don't really have any hidden things going under the hood that you can't understand. However, this comes with some limitations, obviously. And this is important to understand because, as I was saying, the limitations of the context are very important when talking about LLMs, especially regarding web scraping, because you will have HTMLs that are super long. So you have to understand these limitations. That's why it's so important things like the HTML simplification, which is a part of our internal process that will be happening in your machine if you use the extension and you have the code in your machine that you could even decompile and check it. But it doesn't really matter because we will continue improving these things. And the good thing is that if you keep using the extension and providing feedback, we will be improving it. And that's what you're going to be having if you just use it rather than trying to. I mean, we don't really mind if the code is in your machine, right? However, it was very hard. I think we faced many challenges when trying to do this because we had to refactor what we had. We had a complete project behind an API that was being used locally, and we had to adapt it to this. And this is another thing that I want to put out, because I think it's very important when talking about adapting to agents, using agents, for example, VS Code, Copilot. It's something so new, something evolving so quickly that you have to adapt at the same time that you're integrating something. And this is something we have to face, right? We were integrating stuff, and at the same time, the internal APIs were changing. And it was such a mess to work with everything that was stopped working from one day to the next one, because they just changed everything in VS Code. And that's something important to have into consideration. This is extra work that you will have to do when you want to adapt something so quickly to some technology that is growing so fast. How do we know that this is working well? We have internal developers, as I said, working in developing spiders locally for our customers, and they already have used this mini agent behind the API and the bigger agent and this extension in some internal demos we've done. And they have already seen a huge increase in their productivity. We can see, for example, this is just one quote from one of our developers that says that before they would take 8 hours writing a spider, extraction code in particular, and now they are just taking 2 hours. That's a huge increase in productivity. And we have another quote from another of our developers that says that the plugin that we did, the extension from VS Code, looks even more practical than the internal API, because it not only allows you to get the code and get the target values directly, but it interacts with your existing project, and it can adapt better to that. So you don't really have to go copying and pasting if you have the answer from the API and you are working on a different project. So it's more integrated with everything. And then about scaling and efficiency, this is also important to think about, because if you think about it, if you think about Copilot, how it works just in your IDE, in a window to your right side of the screen, how do you scale this? So sure, you can use it to write one spider, one project, but what if you want to write 1,000? How do you do that? Well, you have to put that behind an API, right? But talking about this, we already have this internal API for our mini agent, so we can already scale this. And we are constantly researching ways that we can use this bigger agent, let's say Copilot, in a more scalable way. For example, how to use it with GitHub integration so that it can create PRs automatically for you, and the level of autonomy is bigger. And also, this is something that Microsoft is right now working on it, so it's completely new, and you have to really be checking day after day the new stuff that is coming out. And this is also a very good point. It's some technology that is evolving so fast, you really have to be every day checking what's new and what is coming out. And I know, it's overwhelming. And you really have to, I think companies should have teams dedicated especially to be checking these and having research people thinking how all these new tools can benefit us and what is the best tool, because there are just so many tools out there, and which one is better, which one is best, is just not straightforward to know. Other work that we're doing is not only extraction code, but we're also thinking how can we go beyond, how can we also do scraping? How can we get the scraping logic, which is very complex to calculate, to figure out, because you have to actually navigate the web page. And for example, a user query can be, I want to extract the product data, and this is actually some queries that we've got at site. I want to extract data, but I want to make it very economized. So I don't really want to go into each one of the product pages, but I just want to go to the results page and get the minimum data from there. So that's very specific. And the logic that the spider has to have is very specific. So you really have some guidance there from the user that specifically says you don't go into the pages. And this is just an example. There can be millions of different nuances that you can do in terms of scraping. And we're investigating how we can use LLMs, or how can we do an MCP that helps the agent understand and do a big plan of, okay, this is how I'm gonna write the spider, because this is how the web page is presented, and this is the structure. And another thing is, obviously, we're gonna keep working in this extension, especially with your feedback, and we will always strive to improve it and to get better results for every use case that we're getting. And also, one of the most important things that we would like to do with it is to make it more adaptable to the existing user projects. Also, we have many different tools, like, for example, WebPoet that Adrian was presenting yesterday and showing how it can be used. And we are updating all of these open source tools to be used with LLMs and adapting to the new agents and how they can be used. Another part of our research is thinking, okay, can I maybe not make this mini agent as an MCP, but maybe do something different? Maybe do MCPs or tools that are more adaptable, or like the building blocks for the agent that can help the agent. Can I make something different? Can I just make some generic kind of, query the HTML, allow the agent to use a LLM separately from the entire context of the task that the user is having? Can I use this MCP or mini context to ask something about the HTML? And maybe that way the agent could figure out some ways to, for example, get the target values without using the whole context for the agent, which happens right now if you try to make everything with the agent. And much more. We are really researching how to use all the different agents, what is the best way we could integrate with that and bring our tools to a new level with the agentic stuff that is coming out. So as closing remarks, as some kind of conclusion that I would like you to take, is that really web scraping is really hard, and it has many challenges for agents. It's not just one thing. There are so many points where it can fail, and they fail. Maybe in 2 years, probably in 2 years, this will be completely outdated and they will be able to do that, but maybe they will need help along the way, or maybe, I don't know, what is the solution? Maybe the solution is not making LLMs better or the agents better, but maybe the key is somewhere else. But that has to be researched, and you have to play with it and break it and make it. Delegating hard work, like we're doing with this mini agent and the MCP tool that the extension brings you, is very effective. So we tried, as you saw, we tried the agent to do everything, and this just didn't work. But we're getting things done thanks to this mini agent. This is really helping the main agent to get stuff done. The best scope for MCPs, so how much we delegate, is not trivial. So you could delegate more, but then you lose flexibility. Or you could delegate less, and you get more flexibility, but you will still have the problem. Like the main agent would mess up, and it would know what tool to use, or it would not know how to use it, because it's a very generic tool, so that it's flexible. And obviously, agents are getting so much better as we speak. So probably in 2 months, there will be something new that has to be researched, and you have to understand it very good to know if it's bringing any value to what you're doing and how you can integrate it with your tools. And Zeit is obviously working very closely with all of this to try to improve what we have and integrate it with everything, with all the agent stuff that is coming and all the new technologies. Thank you.
So one question for you. Do you see a method where AI reasoning can be guided to a generalized solution?
Can you repeat the question?
So do you see a method where AI reasoning can be guided to a generalized solution? I guess this is talking about how do we get the slider over to the right? Maybe some of those initial solutions we played with less human in the loop. Is there a way forward for that? Do you see it working?
Yeah, I think it's... So I don't really have the answer, because it's kind of asking, the way I understand the question is really reasoning the holy grail of how LLMs get better? And that's a very good question. I don't really know. I don't know what is the next step. One question that I would like to put on top of that question is, are we plateauing with LLMs? How much better are we going to be able to get with the current technology and how they work? And with this reasoning, yeah, I mean, we see that they're getting better, right? But how much they improved, for example, from GPT 3.5 to GPT 4, it was such an incredible jump. And from GPT 4 to GPT 5, now the feeling from people wasn't so great. Like, obviously, there was a jump, but we don't really know if the current technology is reaching a plateau. It kind of seems like. So what can be done to increase the capacity of LLMs? So we can see, for example, in open source that Q1.3, what they're doing to get close to GPT-5 performance is have being trained to reason, and reason a lot. And I'm really referring to a lot. They're using like probably 20 or 30,000 tokens just for reasoning before giving an answer, and that's coming close to GPT-5 performance. So it kind of looks like reasoning makes them much better. But until what point, that's only time will say.